All right, let's dive deep today. We're going to be tackling AI agents, and we're going pretty technical with this one.
Yeah, it's really interesting. I think what we're seeing here is it's not just language models anymore. We're talking about systems that can actually do things out in the real world.
Okay, so when we say agent, we're not just like,
Yeah.
slapping a fancy label on a language model.
No, not at all. It's more like, well, think of it like this. A language model is like a chef who knows all the recipes. But an AI agent is the chef who can actually grab the ingredients, use the appliances, and kind of, adapt to what's happening in the kitchen.
Okay. So the source material we're looking at today breaks this whole agent concept down into three core components. We have the model, the tools, and then something called the orchestration layer. Let's unpack these. Starting with the model, what is that all about?
The model, that's the brain, right? It's the language model, the LM, that makes the decisions based on its training and all the information it's getting. And these models, kind of like chefs, they can vary in size and type, and even how they've been fine-tuned for specific tasks.
Okay, so the model brings the knowledge. What about the actual doing part? That's where the tools come in.
The tools are like the agent's hands. They're the APIs and connections that let it interact with the outside world. We're talking real-time data, sending emails, updating databases, even controlling physical devices.
Wow, the possibilities are kind of mind-blowing when you think about it. For our listeners, can you give us some specific examples that really illustrate how powerful these tools can be?
Sure. So imagine an agent that uses the Google Flights API to, find the best deals for your next vacation, or one that automatically updates your CRM system with like information it gathers from the web.
That's so powerful. It sounds like a huge upgrade from like traditional AI models.
Yeah, absolutely. You see, a traditional model, it's limited to, generating text or images based on what it's been trained on. But an agent can use that knowledge to actually take action in the real world. That makes it way more dynamic and versatile.
Okay, so we have the brain, the model, and with the hands, the tools.
Mhm.
How does the agent know what to do with all this power? That's where the orchestration layer comes in, right?
Exactly. The orchestration layer is the logic, the recipe that guides the agent's actions. Which tool to use, in what order, how to adapt based on the situation.
So it's like a set of instructions that says, okay, first you check the weather API. Then if it's raining, you suggest an indoor activity, something like that.
Exactly. Things like REACT, which stands for reason and act, and chain of thought prompting, they're really important in this orchestration process. They give the agent a way to gather information, reason through it, and then take action in a logical way, with a goal in mind.
This is blowing my mind already, and we're just getting started. Let's dig into the specifics of these tools. The source material we have talks about three main types: extensions, functions, and data stores.
Let's start with extensions. These are like they're like standardized bridges between APIs and the agent. They make it really easy for developers to connect their agents to a bunch of different services without writing a ton of custom code.
So instead of like reinventing the wheel every time, developers can use these pre-built extensions to connect to things like Google Maps, weather services, even social media.
Exactly. Think about how much easier it is to use a connector for something like the Google Flights API, right? Instead of having to write all that code yourself to handle, the authentication, the data formatting, all that stuff.
Right. The source material mentions a code interpreter extension. Is that something our listeners would find interesting?
Oh, absolutely. That code interpreter extension lets the agent actually run Python code. That opens up a whole new world of possibilities, like complex tasks and data manipulation. Imagine an agent that can analyze data and generate custom reports, charts, visualizations on the fly.
Okay, now that is seriously cool. Now what about functions? They sound similar to extensions, but there are some key differences.
You're right. The big difference is where the execution happens. With extensions, the API call happens on the agent side. But with functions, the agent chooses the function and its arguments, but the actual running of it, that happens on the client side, like in a user's app.
Oh, so it's like the agent makes a suggestion, but the client gets to decide whether or how to actually do it. That seems like it would give developers a lot more control.
Exactly. It gives developers more control over the data flow, the security, the timing of those calls. Plus, it makes it way easier to integrate agents into existing systems, without having to expose sensitive data or stuff like that.
Can you give us a real-world example of how this might work?
Okay, let's say you're building a travel concierge agent. It suggests a list of destinations and your travel preferences to a function. Your travel app can then take that information and use it to like fetch images, book flights, suggest restaurants nearby, all without the agent needing access to your personal data or booking systems.
Okay, I'm starting to see how this all comes together. The agent is like the smart, the orchestrator, but it doesn't have to do everything itself. It can delegate, use the power of the client side to make things more secure and robust.
Exactly. And that brings us to the last tool type we'll talk about today. Data stores. These are important because they solve a big limitation of AI models. Their knowledge is static.
Right, they're trained on a massive data set, but that data is basically frozen in time.
Mm.
And the world is constantly changing, so that knowledge can get outdated pretty quickly.
Exactly. Data stores are like giving the agent access to a dynamic library, always updated. They let agents tap into things like websites, PDFs, databases, all that real-time stuff.
This is where it gets really interesting, I think, for our listeners. We're talking about a technique called retrieval augmented generation, RAY.
Oh yeah, RAY is a game changer. It lets agents go beyond their static knowledge and actually retrieve the most up-to-date information from a massive data store. So instead of just relying on what it was trained on, the agent can dynamically access and synthesize information from, like, everywhere.
Okay, but how does the agent know what information to get from all that data? Does it just like download everything?
No, no, that would be a mess. It uses a technique called embedding matching. It's like tagging every piece of information with, like, a special code that captures the meaning.
So when the agent needs information, it creates a similar code for its question
Yeah.
and then looks for the closest match in the data store.
Yep, you got it. It's like using keywords to find books in a library. But instead of keywords, we're using these embeddings that, represent the meaning.
This ensures the agent is always using the most relevant and up-to-date information, right?
Yeah.
To make better decisions and give more accurate responses.
Exactly. Now, you might be wondering, okay, so what? What does this mean for me? Why should anyone care about this?
Yeah, why should a technical person care about AI agents and all these tools?
It's about control and power. You're not just hoping a language model gives you the right answer. You can actually design agents that achieve specific goals, in a reliable way.
So it's like moving from using like a generic tool to actually building your own custom tools made for what you need.
That's it. And the applications are endless. Think about agents that can automate those boring business processes or personalize learning experiences, or even help scientists analyze massive data sets. We're just getting started with this technology.
It sounds like a whole new way of thinking about software development. But building these agents, doing it right, requires understanding how to make models smarter about using the tools. That brings us to targeted learning, which maybe we should dive into next time.
Welcome back. You remember we were talking about all the cool things AI agents can do, all the tools they can use? Now let's talk about targeted learning, how to make these models even smarter about using those tools.
Right, because we're giving them this awesome set of capabilities. We got to make sure they can use them the right way, safely and effectively, right?
Exactly. It's like giving someone this incredible toolbox, right? Full of, like, super advanced gadgets, but no instructions on how to use them. Targeted learning is all about giving them those instructions.
So the source material we're looking at, it talks about three main ways to do this. In-context learning, then retrieval-based in-context learning, and fine-tuning-based learning. Can you break those down for us?
Sure, let's start with in-context learning. Imagine you give a chef, right, a brand new recipe, a few ingredients, and maybe some examples of similar dishes. They have to use their knowledge and those examples to figure out how to make this new dish.
So we give the agent a prompt, some tools, and a few examples, and let it figure out the best way to use them in that specific situation.
That's a great way to think about it. And it's really powerful because it lets agents adapt to new situations without needing tons of retraining. It's like learning on the fly.
That's amazing. So how is retrieval-based in-context learning different?
Okay, this one is like taking in-context learning and giving it this giant pantry of information and tools. Instead of just those few examples, the agent can now search for relevant information and tools from a data store.
Ah, so it's like our chef has a fully stocked pantry now.
Yeah.
With all sorts of ingredients and cookbooks, they can make something way more complex and, delicious.
Exactly. The agent can pull from a much wider range of knowledge and tools. That means it can give more accurate and relevant responses.
Hey, that makes sense. Now, fine-tuning based learning, that sounds like there's more upfront training involved.
You got it. This is like sending our chef to culinary school. Instead of learning on the fly, they get this intense training focused on specific cuisines or techniques.
So for AI, that means we train the model on a huge data set of specific examples before we actually use it as an agent.
Exactly. With fine-tuning, the model really gets to understand when and how to use specific tools and knowledge, even in new situations it's never seen before.
I could see how that would be super helpful for agents that are, specialized,
Yeah.
like for medical diagnosis or financial analysis.
Absolutely. You can create these super specialized agents that are basically experts in their field. Now, thinking practically, how do developers actually build these agents and put them into real-world applications? It seems really complicated.
Yeah, it does. The source material mentions LangChain and LangGraph as good starting points. What do you think?
Oh, yeah, those are great resources. LangChain is a popular library made specifically for building these agents, connecting the models, tools, and prompts.
And LangGraph is what, like a visual tool?
Yeah, think of LangGraph as a way to visually design and experiment with agent workflows. It lets developers, even if they're not super into coding, create those recipes for how the agent should behave in a more visual way.
That's really cool. Can you give us an example of how someone might use these libraries to build a real agent?
Sure. The source material has a great example about an agent designed to answer questions about a football game. Imagine you ask, who did the Longhorns play last week? And where's their opponent's stadium?
Okay, so that needs information from a few different places. How would an agent handle that?
In this example, they use LangChain along with two tools, SERP API, which lets the agent search Google, and the Google Places API for location information.
So the agent first checks the Longhorns schedule to see who they played, and then uses Google Places to get the stadium address.
Right. It shows how you can combine different tools and APIs to create agents that can solve, multi-step problems. Pretty cool, right?
Yeah, that is impressive for a relatively simple setup. Now, for our listeners who are really ready to get serious about agent development, the source material mentions Vertex AI. What can you tell us about that?
Vertex AI is Google's platform for serious AI development. You can build and deploy production-ready AI solutions on it, including agents, of course. It's got all the tools and infrastructure you need to take an agent from a prototype to, a fully working application.
So it's a really solid choice for developers who want to build agents that are, robust and scalable. What kind of features does Vertex AI have specifically for agents?
Oh, it's got a lot. There's Vertex Agent Builder, Vertex Extensions, Vertex Function Calling, and even an example store. Give you those examples for in-context learning.
It sounds like it has everything you need to take all these concepts we've been talking about and actually build real-world applications with them. What are the advantages of using a platform like Vertex AI compared to building it all yourself from scratch?
Great question. Well, with a managed platform like Vertex AI, you get a lot of things taken care of for you. It's a reliable environment for testing and evaluating your agents. It's got tools for debugging and continuous improvement, all that stuff.
So it handles a lot of the behind-the-scenes complexity so developers can focus on the creative part of designing and refining their agents.
Exactly. It makes the whole process of building, deploying, and maintaining these agents much smoother so developers can focus on, the fun part, solving problems and making cool stuff.
This is all incredibly exciting, but I think we're getting close to the end of our time for this deep dive. Should we wrap things up here or keep exploring in a third part?
I think we've covered a lot already. Let's give our listeners a chance to digest all this. We'll come back after a short break for a final wrap-up and maybe some things for them to think about.
Sounds like a plan. We'll be back in a bit for the final part of our deep dive. Stick with us. We're back. Wow, we've really been digging into AI agents, haven't we?
We have. I mean, we've talked about how they're built, what they can do, all the tools, how to make them smarter. It's a lot.
It is. But it's so exciting. The potential of these AI agents is, mind-blowing.
Yeah, I know, right? It feels like we're moving beyond just AI into something almost like science fiction.
The source material we've been looking at, it talks about a future where agents are doing all these incredible things, automating boring stuff, helping us make better decisions in business, healthcare, even science. The possibilities seem endless.
I know. Imagine agents that can personalize education or give you expert financial advice or even help doctors diagnose diseases better. It could change everything.
It's like having this super smart team working for you behind the scenes. making your life easier, helping you get more done.
Right. And we're really just getting started. It's still early days for agent development, but the progress so far is incredible.
And with tools like LangChain and Vertex AI getting more accessible, I bet we're going to see a ton of innovation in this area.
Oh, yeah, absolutely. It's just the beginning. As developers keep experimenting and pushing things further, I think agents are going to become like way more sophisticated and more versatile. They're going to be everywhere.
Before we finish up today, I want to leave our listeners with a bit of a challenge, something to think about as they explore this whole AI agent world.
I love a good challenge. What do you have in mind?
Okay, so the source material emphasizes this idea of like iterative development for agents. You got to experiment, refine, really understand the problem you're trying to solve.
Yeah, it's like any creative process. You
Yeah.
start with an idea, try different things, and keep improving until you get it right.
Exactly. So here's the challenge. Think about a real-world problem you want to solve with an AI agent. What data would it need? What actions should it take? And how would you use all the tools and techniques we've talked about to, build it and make it better and better?
That's a great challenge. It makes you think about not just the technical stuff, but also the real world impact this technology can have.
And on that note, I think that's a great place to wrap up our deep dive.
Yeah.
We've covered a lot and hopefully given our listeners a good foundation to understand this exciting world of AI agents.
Yeah, and maybe even inspire some of them to, get involved and build something amazing.
Thanks for joining us for this deep dive into AI agents. Check out the source material we mentioned for even more details. And until next time.